Okay, so now we have a strontium-90 source, which is a beta source of beta radiation. You can see the counter spinning away quite nicely. It's about 1.5 centimetres apart. If I move it to about 10 centimetres away, which is about there, okay, and you line it up properly, it's still going more than the background. Okay, you can see it's flickering away more than the background. Okay, because the background was going at about 1 count every 2 seconds or just under. Okay, so that's still counting away. That's 10 centimetres. What do you want me to try? How much? 50? We could try 50. Okay, so 50 is about there. The issue we've got here is making sure that these line up. Now there is a track available which could help to line these up. I'm just trying to line it up. It's probably just, I would argue, it's just above the background radiation count. Okay, it is ticking over. Yep, it's probably just above the background radiation count. Okay, and we might just be able to pick it up at about 1 metre. Okay, if I move it in a bit, let's go to say, let's go to 20. And line it up a bit better. Yeah, so you can see it's flicking over there, so 20 centimetres is definitely there. Okay, so we can see that beta is going to travel further. What did we say beta was? An electron, a tiny single particle, much smaller than a proton and neutron, and so quite a tiny particle. So now we've got it at about 5 centimetres apart. Let's just check that. So it needs to be a bit more. So it's 5 centimetres apart and it's counting away quite nicely. So I'm going to reset it and we can now then try it and see what would happen if we put some different pieces of paper and stuff in. So, okay, let's try the paper that we did with the alpha. Little or no effect. Polystyrene. Little or no effect. Okay, very thin piece of single sheet aluminium. Not much of an effect. Okay, this piece has actually been labelled and it is 0.05 millimetres thick. Okay, so I put that in, not much of an effect. So now I'm going to take out, well, we've got some cardboard, no effect. Okay, so now I've got some aluminium plates. Now these are all marked up. So if you were doing an investigation, you could actually measure, if you use just aluminium, you could actually measure the width of the piece, or the thickness of the piece of aluminium, and then plot that against the count rate. Okay, so here this piece is 0.1 of a millimetre thick, still getting through. Okay, so we've got a variety of thicknesses. We've got 3 times as thick, so 0.3 millimetres, still getting through. Okay, this piece is 0.92, so it's nearly a millimetre thick. Slowing it down a little bit, but still getting through. Okay, 1.7, so nearly 2 millimetres thick. That's definitely getting there. And then this final piece, which is not measured, it's not got a measurement on it, but you can see it's, if I do that, you can see it's probably quite a bit thicker. Okay, let's try that bit. Hopefully it should pretty much stop it getting through. Right, so that piece has stopped it getting through. Now, some of these are marked up with their thicknesses, some aren't, but that you could use some calipers. Engineers here. They're called calipers, aren't they? The vernier calipers, that's the one. We actually got digital calipers, which will actually give you a digital scale and tell you how thick something is, so we can actually measure up the thickness quite accurately. So that is the beta source. We've got 1 to go, okay, which is the gamma source. Okay, so I'm going to put this one away.